Hey guys, how's it going? Today we're going to look at change of subject or formula. Okay, so we're going to look at change of subject or formula. This is particularly an important topic if you're going to advance in your A levels, doing sciences especially. Okay, and then just in general. So what we're going to do is we have 20 questions here. What I'm going to teach you is how to manipulate some of these formulas to make whatever subject that you want. Okay, so it might be X, it might be A, or anything. Here we're actually told that we're just supposed to make the subject of the formula the letter that's highlighted. Okay, so this one will be very interesting, and we're going to do 5 questions at a time, 5 questions every video. I guarantee you that in your exam there will be some question on change of subject or formula and also on substitution. We are only going to cover one part. Okay, and this topic, it actually overlaps with other topics as well. Just understanding it enhances your math such that you are better prepared when you write your exams. Okay, so what we're going to do is we're going to pick out 5 questions from this pool, and we're going to do it in the order of, from easy to more complicated, and then the next time we'll also do the same. So the first question that we'll do is this particular one, year A. You're told to make S the subject of the formula. So what I want you to commit to mind here is change of subject of formula. It's simply a rescue operation. You want to rescue the letter that's highlighted. You rescue the letter that's highlighted by making it stand alone in an equation. So for example, here you'd be having t, you want to make t the subject of the formula. So it means that given expression, which is the equivalent expression of what's given, and it's given in the form t is equal to something. And the expression that you have that gives the value of t should not include t. Okay, so what I mean is, if you have x equal to x plus y like this, this is not a change of subject or formula. You haven't made x the subject of the formula. Why? Because x still appears on the right hand side. So you're actually supposed to make sure that x or whatever subject is required, it has to be standalone and on one side. Okay, so we're going to do the first question, and then I'm going to illustrate what I mean. So first question says A is equal to S squared. This is a formula for area of a square. So area of a square is equal to side squared. Okay, so you want to make S the subject of the formula. What do? So you should, wherever you want to isolate a variable, what you do is to do the reverse of whatever is done there. So for example, here it's S squared. So it means that S is squared. In order for you to get S there, you have to reverse what's done. And what's done is squaring. And then the opposite, the mathematical opposite of squaring, it's actually square rooting. Okay, so what you're going to do is to say square root here, and then you're going to get S is equal to square root of A. Okay, so you have made S the subject of formula here. Okay, so this is how you do it essentially. So question 1 was very simple, and just take note of there's indices here, the power. And another way to do the same thing, essentially accomplishing the same result, would be to say, and this one it's applicable in all cases. So that's why I really like it. So here it says to the power 2. So in order to get rid of to the power 2, what you do is you say to the power of the inverse of 2. The inverse of 2, it's actually half here. So it'd be S squared to the power half. The reason I'm doing this is that there is a law of indices that says that a to the power x to the power y is equal to a to the power xy. So for me to get a, I should get xy as 1. Okay, so for example here, this 2 would cancel and be 2 multiplied by its reciprocal, which is half in this case. You'd get just s. So you get s is equal to, so this 2 and this 2 would cancel, and then you get a to the power half. And wherever you're given a to the power, or any number or any variable to the power a fraction, what you do is you put your square root first, and then you put a. on this part here, you're supposed to put the denominator. Okay, that's the rooter. The denominator is the rooter. So if you want to, you can say 2 here. But normally, square root, we just put here. We don't put the 2. For the same reason, let's say 1x, we don't put 1x. We just put x. Okay, it's just a matter of convenience. So we don't actually write anything there. So it's just square root and then 2. And then this numerator becomes the power now. So it would actually be in brackets and then to the power 1. For the same reason, we don't put the square root, the 2 and the square root there. We don't also put the 1 is a power, because any number to the power 1, it's simply that number. Okay, so you get this formula here. The reason I wanted you to go with this is sometimes you may be given, let's say x equal to, let's say x to the power 3 over 2 equal to y, like this. And then you're supposed to make x the subject of the formula. Instead of going around and then doing it in steps, what you can do is you can realize that x to the power 3 over 2, in order for you to get rid of 3 over 2, you just need 2 over 3, the reciprocal. Okay, so it'd be y to the power, what you have done on the left hand side, you should do on the left hand side as well. Okay, so when you're doing a change of side of the formula, and then you have two terms, one on the left hand side, one on the right hand side, whatever you do on the left, you do on the right as well. So here I've introduced this power here. The reason I've introduced the power here is so that I can get 1 here. And notice that 2 over 3 is just the reciprocal. Reciprocal means you're having 3 over 2 here, and then you flip it. You actually, just the numerator becomes the denominator becomes the numerator. And then you'd get this value that we get here, okay? So it would yield x equal to y to the power 2 over 3 like this. So if you want, you can even, because sometimes they're numbers, right? So you can simplify them. So here, you put your square root first, then you put y, then you put your brackets. The denominator, we say that it comes here, that's the rooter. The denominator here, it's 3, that's the rooter, and then the power, the numerator. Okay, so you'd get this much, and that's it. This is why I like using cancelling using the reciprocals instead of doing the square root. The square root, it's limited. If you have this question, then that's good for you. But then if you don't have this question, then you actually have to improvise and do something differently. We're going to move straight away to maybe we could do F. Okay, so let's do F. We've done this one, and then now we're doing F. So F, it says A equal to half R squared theta. Okay, so this is area. It's equal to half R squared. So this is the area of an equilateral triangle where theta where theta is in radians. Okay, so we usually use it in where we are dealing with circles. Okay, circles where the angle of theta is quoted in radians. Okay, so physics stuff. But essentially here we need to rescue R. Rescuing R here requires us to go in steps. Okay, so the way that most people would do it is you'd actually say half R squared, and then realize that half, you get rid of half here by just multiplying by 2. Again, notice that half and 2, they are reciprocals. So it means that you are creating a number here such that you can get rid of half. Okay, so here you'd get 2a. If you're really good, then you don't have to cancel here, so that the examiner can see you're working okay, so that they can see that you introduced 2 here. So you'd get this. And then you have to get rid of theta again. So you have to divide by theta here, by theta here. So you'd get, sometimes I actually switch, okay? If you want, you can get this one here. So I'm going to use the space. And then you get R squared here. I'm just, writing this one first. It's equal to 2a over theta, like this. So now we have the same scenario that we had previously. So you can actually go ahead and write R equal to square root. So you're square rooting both sides. Okay, so square root of this. And notice that we did this at a time when we only had R squared here made the subject. Okay, so here this was lousy. I was actually supposed to put square root on each side, just like this. And then you get this. There's another way to actually work this out in fewer steps than what we did right now. And here is how you do it. So let me just delete. So the reason I want to teach you this method is so that you can be fast in your working. Okay, there's no need to go round and round. Sometimes you can actually combine steps. So you just know that you want to get rid of half and you want to get rid of 2. So why don't we do it in one step? So how do we do it in one step? Just multiply by 2 over theta. So the reason I multiply by 2 over theta here is that the denominator theta, it gets rid of it gets rid of this theta here, and then the 2, it gets rid of this 2 here. So whatever we do on the left hand side, we do also on the right hand side. So it actually get 2a over theta here is equal to, then this one we say that they will cancel. To illustrate, I'll actually cancel. So this one, and this one, and yeah, here you'd get r squared. So again, you can write this in a different step and say r squared equal to, so that the examiner, at least the examiner can see the step here. Then you can say square root. So r is equal to square root of 2a over q. Okay, so that's it. You're done. This is the way that I would advise. We see that we combine 2 steps in just a single step, which was really good. Okay, so that's it.